Welcome. This is Polynomials Pre-Assessment Detailed Answer Key. We are combining polynomials. We're adding, subtracting, multiplying, dividing. We're taking powers of a power. So lots of fun stuff to cover here. First one, we are adding and subtracting. We're combining like terms. Remember, like terms have to have the same variable. Let's get a little bit smaller. They have to have the same variable. Now this has the same variable also, but notice the differences. This has the same variable, but different exponents. So this like term would be r to the third. These are like terms. This would not be a like term. That terms, this variable to the second, the like term would be this one with identical variable and identical exponent. And when we combine like terms, so we will be combining this term with this term, and then we will be combining this term with this term. When we combine like terms, we just combine their coefficients. So we're going to combine 1r to the third with 8r to the third, and negative 8r squared with negative 5r squared. So we'll just be combining coefficients. So we'll combine the, let's do that. We'll combine the 1 with the 8, which would give us 9r cubed, and we'd combine the negative 8 with, oh, I did do it wrong. I did the wrong color. Sorry, I wanted blue with blue and green with green. So positive 1 with positive 8 and negative 8 with negative 5. And that would give us negative 13r squared. Now we have to make sure that it's in standard form. Standard form is alphabetical order. And when we're tied with the variable, like we are in this case, we do exponential order or descending order. So r to the third is always going to come before r squared. So this is, oh man, Mr. Mac's making a lot of mistakes right now. So this would be our answer, 9r to the third minus 13r squared. Let's try number 2. So let's look for some like terms. We have negative 5b and negative 4b. So we will combine those two. We have 3b to the fourth and 4b to the fourth. We're going to combine their coefficients. Negative 5 and negative 4 makes negative 9b. Positive 3 and positive 4 makes positive 7b to the fourth. Make sure it's in standard form. So we do 7b to the fourth minus 9b. Notice that negative right there. Notice that negative there stuck with the negative 9. Negative 9 stays negative 9. Positive 7 stays positive 7. But we need it in descending order, so that's why b to the fourth comes before b to the first. Let's get some like terms here. We have negative 2v and negative v. We have constants of 5 and 4 that can be combined. Negative 2v and negative v makes negative 3v. Positive 5 and positive 4 makes positive 9. We have r to the third and r to the third. And then we have two constants here. So 5r to the third, negative 7r to the third is negative 2r to the third. Positive 2 plus 5 makes positive 7. Number 5, let's pair it up. N to the third, n to the third, n and n. We have 3n cubed plus 5n cubed gives us 8n cubed. Negative 2n and positive 2n make 0. It does not make n. A lot of students think that the negative 2 and the positive 2 cancel and leave you with the variable n. Not the case. Negative 2 and positive 2 make 0. So we don't have any n's left. So my answer is just 8n to the third. We have negative 5x, and a pair right here, negative 7x. We have positive 4x to the fourth. We have a negative 3x to the fourth. And then we have our constants. So this time we have 3 pairs of like terms. So negative 5x and negative 7x makes negative 12x. Positive 4x cubed, negative 3x cubed gives us positive x to the fourth. Negative 7 and negative 6 makes negative 13. We got to make sure it's in standard form. And that would be my answer. 3b to the fourth, negative 3b to the fourth, negative b, positive 7b, negative 7, positive 7. Lots of things are going to cancel here. So 3b to the fourth, negative 3b to the fourth equals 0. Negative b and 7b gives me 6b. Negative 7 positive 7 is 0. So we get just 6b. 5x squared, negative 8x squared, positive 6, positive 6, positive 2x to the third, negative 2x to the third. 5x squared, negative 8 makes negative 3x squared, positive 6 makes 12. Those cancel, and that's my answer. Negative 6, positive 3, negative 2m cubed, positive 2m cubed, negative 7m, negative 7m. Negative 6 and positive 3 makes negative 3. Negative 2m cubed cancels with positive 2m cubed. Negative 7m and negative 7m is negative 14m. I'll write the variable always before the constant. 3r squared, 3r squared, 7r, 4r, negative 6r to the fourth, negative 5r to the fourth. 3r squared is 6r squared. 7r, 4r makes 11r. Negative 6r to the fourth makes negative 11r to the fourth. So we're going to do the variable alphabetical order. So we only have one variable, r. So r to the fourth is going to come before 6r squared, which is going to come before 11r. 4, that's interesting, even though I did that. R to the fourth, R to the second, R to the first. Descending order based upon its variable. Let's make sure I wrote that, transferred that. That's good. That would be our answer. Negative x, positive 8x. Ooh, look at that. Y to the fourth, y to the fourth. Like this. This is really good. Negative 8x to the fourth y does not have a partner, and nor does negative 4y squared. So negative x and positive 8x makes 7x. 8y to the fourth, negative 7y to the fourth gives me just y to the fourth. We have the negative 8x to the fourth y and negative 4y squared. Love this. This is a really good one. So what is the first variable in each of the terms? We have x and y to the fourth. We have x, y, x, and y. So we're going to just compare these x's first because x comes before y. These y's would come that y, this, no, let's not use yellow. This y, this first term y, and this first term y is after these x's because our first term is an x, so x is always going to come before a first term y. So now we have to look at these x's. This is x to the fourth. This is x to the first. So my tiebreaker is going to be the exponent. So I have negative 8x to the fourth y plus 7x. So now I've done my x's. Now I got to do my first term y's. We have y to the fourth and y to the second. So that's going to be y to the fourth is going to come first, and then negative 4y squared. Okay, so that's always very tricky. You got to know all of your standard form rules. So there would my answer. My answer would be that. So we have x to the fourth. Yeah, I knew that was going to happen. Oh, now that's in the way of the next problem. So we have x to the fourth, x to the first, y to the fourth, y to the second. Notice this y never came into play because we didn't have, it didn't go to the tiebreaker where we went this. First tiebreaker is the first variable. Second tiebreaker is the exponent. If we're still tied, then we go to the next variable in the problem. Let's see if that ever happens. So let's look for like terms. We have m to the third, n to the fourth, m to the third, n to the fourth. Those are like terms. We have m squared n. We have m squared n. So these are like terms. Now you have constant, and I think I have all my terms. So now we're looking at coefficients. So negative 1 m to the third, n to the fourth, and positive 6 gives me 5 m to the third, n to the fourth. Now we're looking at the green ones. We have a negative 2 and a negative 8, which makes negative 10 m squared n. And then we have positive 3 and negative 1, which makes positive 2. Now let's see if they're in standard form. So my first variable is m. My first variable is m. So those are tied. So now I have to go to the exponent. M to the third is going to come before m to the second. So this is in standard form. This would be my answer at the end. Ooh, these are getting good. Y squared, xy cubed, xy cubed, xy squared. These go with those, that goes with that, and this goes with that. Now we're going to look at coefficients. Positive 8, negative 7 makes positive 1 y squared. Positive 4, negative 1 makes positive 3xy cubed. Positive 4, negative 2 makes positive 2xy squared. So let's look at the first terms. We have a y, we have an x, and an x. So these x's are going to come before this y. I know this is going to come last. So now we have x to the first, x to the first. So we're still tied. X to the first, x to the first. Sorry, we have x and x. Then we go to the exponents. Exponents are 1 and 1. Now we go to the next variable, y and y. We're still tied. And now we have to go to the exponent. That's 4. That's the fourth degree that we had to go down there. We went first variable, then exponent, then second variable, and now the exponent of the second variable. So 3 is going to come first, third. So we get 3xy to the third plus 2xy to the second plus y squared. And that would be standard form. That's it. If you got that one right, you have a very good understanding of standard form. That is probably one of the best tests or questions to ask to see comprehending of standard form. That was a doozy, a doozy. We have a squared b cubed, a squared b cubed. Now we're dealing with coefficients, negative 8b, positive 7. Oh, I almost made that mistake. That's why it was good that I connected the lines. I almost connected the negative 8b and the positive 7a, but they're not the same color. Negative 8b and positive b gives me negative 7b. Negative 6a and positive 7a gives me a. Negative 2a squared b cubed, negative 7a squared b cubed gives me negative 9a squared b cubed. Looking at the first variable, b, a. So a's are going to come before b's, and then my a's are not tied for their exponents, so this one's going to come first. Negative 9a squared b cubed plus a minus 7b. Let's make sure I have the exponents correct. Good. And that's correct. Let's pair them up. A squared b squared, a squared b squared, ab, a to the fourth b, a to the fourth b. Coefficients 5 and 7 makes 12a squared b squared. Negative 2 and positive 8 gives me positive 6ab. Negative 3 and positive 3 gives me nothing. And this is in standard form also because a squared is going to come before a. All right, let's multiply now. Now, when we multiply like, actually, they don't even have to be like. When we multiply, in this case, they are like, which isn't maybe the best starting problem, but when we multiply terms or monomials, we have a monomial times a monomial. We understand that negative 6 is multiplying n to the fourth, which is also multiplying 8 times n to the fourth. So we're going to always combine these constants. We have negative 6 times 8, and then because we have like bases, we're only concerned about their base, not their exponents. When we multiply like bases, we are going to add their exponents. So this gives me negative 48 n to the 8th. That would be the answer to number 16. You'll see a little bit more. So we have negative 5 times x to the third times negative 7 times x to the negative 1. So we're going to multiply the constants, negative 5 times negative 7, and we're going to have like bases. We have x and x. When we multiply like bases, we add their exponents. Negative 5 times negative 7 gives me 35. X to the 3 plus negative 1 is 2. And we get 35x squared. We have negative 3 times x to the third times negative 3 times x to the fourth. We're going to multiply that negative 3 times the negative 3, the constants, and then x to the third times x to the fourth. Well, since we have like bases, that's going to be 9x to the 3 plus 4, or 9x to the 7th. Number 19, negative 2 times p squared times 7 times p to the third. Constants, like bases, gives me negative 14p to the 2 plus 3, or negative 14p to the 5th. Love these. Negative 6 times n times 2 times n to the negative second. Constants, negative 6 times 2, n times n to the negative 2. Those are like bases. So we get negative 12n. There's an invisible 1 there. So that's 1 plus negative 2, which gives me negative 12n to the negative 1. Now, we can't have negative exponents. In the directions, it said, in the directions, in the directions, I think it's at the bottom of this page, it says your answers should only contain positive exponents. Positive exponents. Negative constants are okay. Negative constant, this is a negative constant, that is okay. It is the exponent that I am concerned about. So this has a negative exponent. When I change that negative exponent to a positive, I'm going to change the location. It is currently in the numerator. this always takes place in the numerator. So my negative 12 has an exponent of 1. We don't see it, but it's not attached to that negative 1. The base of this exponent is only n. So we have negative 12 stays in the numerator, and then when I change this negative exponent to a positive, it goes down into the denominator. Notice I didn't write n to the first because we don't need to, but if you wanted to just see that, that is the only answer that we're going to use. All right, so that was a little tricky. Lots of fun stuff to deal with there. So let's deal with this again. Negative 6 times x to the third times y to the 0 times 8 times y to the negative 3. Let's match up the constants. Let's match up. No like variable on the other side. We have y to the 0 and y to the negative 3. So I'm putting them in alphabetical order. Didn't look like that, but that's what I did there. Negative 6 times 8 is negative 48. X to the third didn't have a partner. Y has like bases, so that's 0 plus negative 3, which gives me negative 48. X to the third, y to the negative 3. I can't have that negative exponent, so I'm going to have to move this base down into the denominator. It's going to go down into the denominator, and I get negative 48. X to the third stays in the numerator, and that y to the third comes down. So you'll notice that went from negative to positive. When I change it from the numerator to the denominator, the sign of the exponent changes, and that would be my answer. Number 22, we have 3 times u to the negative 1 times v to the 0 times negative 8 times u squared times v squared. We have 3 times negative 8. We have u to the negative 1 and u to the second. We have v to the 0 and v squared. That gives me negative 24. U to the 1, negative 1 plus 2. V to the 0 plus 2. Negative 24 u v to the second. I don't write a 1 next to that u because it's understood. Oh, I like this. Negative 1 times x to the 0 times y to the 0 times negative 2 times x to the fourth times 4 times y times x to the fourth. So let's deal with those constants. We have negative 1 times negative 2 times 4 times x to the 0 times x to the fourth times x to the fourth. We have y to the 0 and y. Negative 1 times negative 2 is positive. 2 times 4 is 8. X to the 0 plus 4 plus 4. Y to the 0 plus 1, which gives me a final answer of 8 x to the 8th y. Another good one. These are really good ones. These definitely, if you're getting these right, you're pretty good for the assessment. Negative 1 times u squared times v to the fourth. So we have 6 times negative 1, u to the fourth times u squared times v to the third times v to the fourth. That's negative 6, u to the 4 plus 2, v to the 3 plus 4. Negative 6, u to the 6th, v to the 7th. And those variables have to be in alphabetical order. That term, uv, xy, uv. There might even have been an AB. All right, 25, the last one of multiplication. 7 times x to the negative 4 times y to the negative third times 4 times x squared times x squared. Ooh, look at that little tricky one. Constants first. X to the negative 4, x to the second, y to the negative 3. We get 28, x to the negative 4 plus 2, y to the negative 3. That gives me 28x to the 0, y to the negative 3. We know that x to the 0 is equal to 1, so it's like multiplying by 1, which isn't going to change it. It still stays 28. And then you have y to the negative 3. I have to get rid of that negative exponent. So this term has to go down. So my final answer is 28y to the third. Don't forget to change that exponent from negative to positive when we change its location. Now division. So division, you see how I switched this, split it up and everything? You can do that also. Take the constants, make it separate. And then we have like bases. When you have like bases and you're dividing, you're going to take the numerator, the exponent of the numerator. So it's r to the 4, there's my numerator, minus, and that minus is represented by the division. That division, the dividing of like bases, creates a subtraction. When we divide like bases, we subtract. I'm going to move that out a little bit. We subtract their exponents. So that negative here is represented by the division part. And then we divide the denominator. So minus 0. And that 0. So it's numerator minus denominator. Numerator in green, minus is division, and then 0 is the denominator. And what does that leave us with? Well, 6 over negative 6 is equivalent to negative 1, r to the 4th. 4 minus 0 is 4, and I would never leave that as negative 1. I would leave it as negative r to the 4th. That is the only answer I will accept for that. 27, so we again have coefficients. And notice that this subtraction, this happens, that's the numerator. That's in the numerator. Even though it looks like it's in between, we are notating it as a numerator. 6 over 3 is 2. X to the 3 minus negative 1 is 4. So you get 2x to the 4th. Negative 7 over negative 2, n to the 0 minus 1. These, when a negative is divided, we're dealing with constants. When a negative is divided by another negative, we end up with a positive. So we get 7 halves n to the negative 1, which is 7 n to the negative 1 over 2. Remember, this happens in the numerator. I just wrote the two numerators together, 7 and the n. And then notice that I have a negative exponent. So that base needs to go down, which gives me 7 over 2n. And I'm not going to write 1. That's a good one too. There's some really good testing. So our fraction 4/7 n to the 1 minus negative 1. How many people made a mistake there? How many people wrote n to the 1 minus 1? I know you were there. I know, because it's 1 minus the negative 1. That division, this division is represented in that subtraction. This negative in front of the 1 is the denominator, and that 1 up there is that 1. There's an invisible 1. So we can't reduce 4/7 n to the 1 minus 1 is 2, and then that's okay, but this is the best answer. This is what we want to see. That's what high schools want to see. You could give 4/7 n squared. I'm okay with that, but that's the better one. This negative, so we can pull that negative down, and we can write 1 over negative 6 as our constant, and then x to the 3 minus 2. That negative can go anywhere, but I'm just going to put it down there to keep it nice and cozy. X to the 3 minus 2 is x over negative 6, and that's the correct answer. You could have written negative x over 6. That negative could be in the denominator and numerator, and then the other or is negative x over 6, where it's even with it. Any of those, don't give me all three of them, just give me one. Same thing here. We have a negative outside. That's going to be tricky with all this other noise that's going on. So I'll just write -1. And we'll put it in the numerator. We have y to the 4 minus 0. And then this x to the -4 doesn't have a partner. So it's in the denominator. So I don't have to, I'm just going to keep it down there because it doesn't have a partner. This y, because I'm subtracting like bases, or I'm dividing like bases, that subtraction part takes place in the numerator. We have -y to the 4th over x to the -4. Now I have a negative exponent. That base has to change its location. It was in the denominator. It now goes in the numerator. And notice I put it in alphabetical order. X is going to come before y. Another tricky one there. 31 will be interesting to see how many people got that. We have -5 over 5, x to the 4 minus 3, y to the 2 minus 2. 5 over 5 is equal to 1, so we just have the negative. X to the 4 minus 3 is 1, and y to the 0. And that just leaves us with -x. Y to the 0 is equal to 1, multiplying by 1. 8 over 6. A to the 3 has no partner, and it's in the numerator. B to the 2 minus 4. 2 goes into 8, and 2 goes into 6, so I'm going to reduce that to 4/3. A to the 3rd, B to the -2. The A to the 3rd is going to stay in the numerator with the 4, and the B, the negative B to the -2 is going to go down with the 3 in the denominator. Nice. So good. -2 over -6, x to the -3 minus 2. The two negatives are going to cancel and make positives. 2 goes into 2 and 2 goes into 6. That reduces to 1/3. X to the -5. I'm going to put that x to the -5 in its numerator because that's where this is. That's in the numerator. So when I write it as one term, and now, because it's a negative exponent, I'm going to move it down. When I move it down, there's nothing up there but a 1. It is not 0. It's not 0 in the numerator. It's a 1 in there. So 1 over 3x to the 5th. Yes, good stuff. -8/6. We're going to pop that negative up to the 8 for no reason other than I just did it. Oh, see that? I almost made that y squared. And that would have been bad because this says it's in the numerator, but we see it's in the denominator. So be careful of that one. Wonder if somebody else, let's do this then. Let's put this in the numerator because that's where that dividing like base is. And then let's write the y squared down there. Let's keep it down there. So -8 over 6 can be reduced to -4. X to the 3rd over 6y squared. That's a good one. Oh, hello. 4/6, 4/3, Mr. Mac. Almost made a mistake. And I think, now we get into powers of powers. Now, when we have the power of a power, we are going to multiply those exponents. So that becomes r to the 6th. Remember, this exponent goes to each of the pieces in the parentheses. We have a 3 and a v cubed. So that square has to go out to each of those pieces. That's 3 to the 1 times 2 times v to the 3 times 2. We are distributing that exponent into the parentheses. That's 3 squared, v to the 6, and 3 squared is 3 times 3, or 9v to the 6th. Now you see that we will also distribute negatives. 1 times -1, v to the -3 times -1. That becomes 4 to the -1. Ooh, we haven't done any of that. v to the 3. Negative 3 times positive 1. So even with a constant, we have to get rid of it. The v to the third stays in the numerator. The 4 to the first goes to the denominator. And since we don't have to simplify that, that would be our correct answer. That's 2 to the 1 times 3, m to the 3 times 3, which equals 2 to the third, m to the ninth. 2 to the third is 2 times 2 times 2, which is 8, m to the ninth. Distribute this, 2 to the 1 times negative 3, u to the 2 times negative 3, v to the negative 3 times negative 3. 2 to the negative 3, u to the negative 6, v to the ninth. This is all in the numerator, remember. Now I'm going to get rid of this. I'm going to change that. That means it goes into the denominator. I'm going to change this. That means it goes into the denominator. And then my v to the ninth stays in the numerator. I can simplify 2 to the third. That still equals 8. So we have v to the ninth over 8 u to the sixth. Nice. Last couple. 5 to the 1 times 3, a to the 2 times 3, b to the 3 times 3, 5 to the third, a to the sixth, b to the ninth. 5 times 5 is 25, times 5 is 125. A to the sixth, b to the ninth. 2 to the 1 times 2, y to the 3 times 2, 2 to the second, y to the sixth, 4, y to the sixth. And I think the last problem, 6 to the 1 times 3, y to the 2 times 3, 6 to the third, y to the sixth, 6 to the third I think is 216, y to the sixth. And I think that was it. Woo! That may have taken almost an hour to do. Good luck. Come and see me if you have questions. Awesome work. Keep working hard.